Okay, we're going to get started now. So thanks everyone for coming. We try to do these meetups about once a month, as Phil stated. This is the first time we've done anything, I think, hardware related. Is that right?
Yeah.
So we're going to try to give you as much information as we can. We had you complete a survey and to try to get an idea of some of the skill levels of the kids so that we could tailor this appropriately, but it was a pretty wide range. So we had everything from zero experience programming to some kids are designing websites and even going beyond that. But it seemed like nobody had really worked with the Arduino much yet. Has anybody here worked with the Arduino? A little bit? Okay. So we're not going to be able to tell you everything today, but try to at least show you how to get started with it. And then we'll be available if you have questions down the road. Feel free to hit us up with that. As I mentioned, this presentation and some links and I guess this videotape and other things, we'll post everything we can online so that you can access that later. All right, so let's just get started. Let me just show you. So an Arduino, it's something called a microcontroller. And what is a microcontroller? Does anybody know? Any ideas what a microcontroller is? So it's basically like a little computer. It can't do everything a computer does. It has a small amount of memory, so you can't put necessarily huge programs on it, but you can put very specific programs on it that do one kind of thing. Your computer can do so many things, right? It can read DVDs, and it can surf the internet, and it can do spreadsheets and word processing, and you can put a tablet up, connect a tablet to it, and you can draw and things like that. Phil, as people come in, can you make sure they fill out the ticket? Yes. Whereas a microcontroller can really do pretty much just one specific thing. You tell it what you want it to do. It can react to something. Now the cool thing about the Arduino, and I'll show you here, it's just this, holding up a bunch of stuff here, it's just this blue part here. Okay, that's an Arduino. That's how big it is. It's not very heavy. There are actually different versions of them. This part here, I'm going to show you this contraption later, but just this black part here, that's another kind of Arduino. It's smaller so that like if you need to get it inside something, or like this one, it's going to propel some wheels here, it can't be too heavy. And there's even, I don't know if you can see it, but this little thing here, inside this pink thing, this little thing is about the size of a little bit bigger than a postage stamp. That's also an Arduino. Now that you can't just plug things into it. That requires you to wire things up a little differently, but it's really small, really light, so maybe if you had like an airplane or a little helicopter or something that you wanted to, yeah, just put in that box there, thank you, that you wanted to program and do different things, this is a nice light little thing. The Arduino, the basic one, costs around, different prices, but it's around $30. This little guy here is only about $15. But again, it's harder to work with. It takes more time, takes more detailed work to work with it. And there are also you can go online and search for them, because the Arduino is something called open source. Open source means they put all of the schematics online, all the parts. You can build your own Arduino if you get all the piece parts. Basically, the directions for how to build it are online. So there are other kits you can buy online if you're comfortable. Of course, I can't find it now. But if you're comfortable soldering, okay, and working with electronics, you can buy some of these things really inexpensively, around $12, $15, and then you kind of build it yourself. But this thing here is ready to go. This $30 one. So what happens is, and I'm going to show you how to do some of this stuff later, but there's a little programming environment. Again, it's open source, it's free. You can download it from the Arduino website, and it works on Windows, it works on Mac, it works on Linux. So it works on pretty much all the laptops that are out there, or all the computers that are out there. You can write a little program, you upload it, you connect it to the Arduino with just a USB cable. You push a button, send it over there, all of a sudden your program's now on the Arduino. And you can run a little experiment, see if it works or not. If it doesn't work, you can go back in, make some changes, send it up there again. You can just keep doing that forever. Another nice thing about it being open source, and there's a really good community out there, people doing, a lot of people are doing this. You can find other people's programs. They just post them online. You can copy them, put them into your Arduino, you can make changes to them. All these, I'm going to show you 3 projects here. There's another guy, Hugo, was supposed to show up. He hasn't made it yet. He was going to show 2 more, but regardless, all these, I didn't invent any of these. I found them online. I made some little changes to them, and I'm going to show you how we can make more changes. We're going to do that right here. So you upload your program to the Arduino, and what kinds of things can it do? It can respond to the environment. You can get little sensors, and I'm going to show you one of those examples in here. Light sensors, something to tell you how bright it is. Motion, if something moves. GPS, probably most of you are familiar with GPS, you know, in the car, helps you navigate. GPS tells you where you are. You can use the GPS to tell the Arduino where it is, and maybe it does something when it gets in a certain area, that kind of thing. So information can come into the Arduino, and you can write a little program, tell it what to do, and then you can send digits out to certain parts of the Arduino, hook up wires to it. You can light up lights, move wheels. You could even have the Arduino tweet on Twitter. I saw an example where someone had one that I think it was connected to a coffee pot, and I think it every morning at a certain time, you know, it made the coffee, and then it would tweet on Twitter, "Coffee's ready," you know, things like that. So there are lots of things you can hook these up if you have a smartphone, Android or an iPhone. You can do things on your phone and have it transmitted to the Arduino, and the Arduino will react to that. So the possibilities are just amazing. It's you can do really just about anything you think of. Now, so here's a zoom in of the Arduino, and I just wanted to give you a real basic understanding of what's on there. So that part there, that's where you plug in the USB. Now the purpose of the USB is to send your program. In Arduino speak, we call that a sketch. You send your sketch into the Arduino, and it also gives it power. There's a thing down there though where you can plug a battery into the Arduino. So if you don't want to be connected to the computer, and I'm going to show you a couple of the examples I have here today, they're just free. They're not connected to the computer, and you can take them with you and they can move around. So there are, now these, around the edge you're going to see there are these black squares, okay? That's where you plug wires into it. And I'm not going to go into a whole lot of detail on this right now unless there's some questions, or we can talk about it later, but whatever. But just an overview. That's where you can, if you need power, say to, for example, the wheels on this one contraption here, they need power. So they have to plug into that to have enough energy. That's the brains of the Arduino. That's the mini computer on there. These are what are called analog inputs. That's where I told you could plug in a light sensor or something else, where you could let the Arduino find out what's going on out in the world, and it gets the data in and it works with it. And up here we have digital pins. These can be both inputs and outputs. And this is where if you want to make a light flash or make a buzzer go off or something like that, and you'll tell. And if you notice up there, I'm gonna put this down for a second here. All these pins are numbered. Starts at 0, goes up to 13 here. This is A0 to A5. And that's important to know. They're in order like that. That's important to know because when you write your program, if you want a light to light up or something to happen, you have to tell it, okay, I'm going to plug a wire into D7. It stands for digital. That'll be in the digital area up there on the top, number 7. And you just tell that in your program, and then it'll know to send a signal there and light up the light. So these are some components that are very common to work with the Arduino. On the upper left there, all those colors, those LEDs, light emitting diodes. You can go online, you can buy those, they're very inexpensive. You can even go to Radio Shack and get, I don't know, I can't find anything. You can get bags of them pretty inexpensively. Well, anyway. Down below in the lower left is a thing called resistors. And you just have to know about them right now. But you need, when you copy a project online, often it'll say put a 10K resistor in there. And there's a free app you can get. I'll post that also in the links for a smartphone. And if you're not sure, there's little color bands on those resistors, and it's a little code. And it'll tell you, okay, a 10K is a orange, orange, brown, or something like that. So you'll just be able to do that. And what that does is it keeps, it helps the circuit work better. I don't want to get into too much detail on that. And then this thing in the middle here, this thing is called a breadboard. Has anybody heard of a breadboard before? You guys have? Okay. Well, in the breadboard, just a bunch of holes, a bunch of squares, right? But the way a breadboard works, it makes it really easy to connect things, to connect wires and different things without having to twist them together or solder them or get all messy like that. Essentially, everything in this row here, each little row is all together, connected together. So if you plugged in something here and another thing here, they would actually be connected. And then you can connect from here over to here, nothing, and the wires just plug right in. It's real easy. And I'm going to show you on some of these things here how that works. Okay. Okay, so I mentioned the sketch before. I got to keep moving over there. So this is about the simplest sketch you could do. This is the thing that allows a light, an LED, to blink. And I'm going to go in a little bit more detail on the next slide, but essentially it has 3 areas. There can be more, but at a minimum there are 3. So this upper area here is where you define, we call it defining your variables. So here we're just saying that the LED equals 13. That's because we're going to plug an LED into pin 13. So we have to tell the Arduino where we're going to put the LED. So it's real simple, LED pin 13. Then we have a setup area here. And everything in this language, this is called processing, this block here is defined by these braces, and then you put instructions here. And then it's saying the LED, which we set up here, is number 13, is going to be an output. You have to tell whether the pin up there is an input or an output. Means we're going to tell that thing, we're going to send information out to tell it to light up. And then down here we have our loop. Okay, and the loop, this is the main body of your program. You put all the instructions that you want to have happen. This one is, it says digital write to the LED high. That means it's going to turn it on. And then we delay for a little bit so the light goes on. We wait, because if you didn't have these delays in here, the Arduino is so fast that if you told it to turn on and then down here we tell it to turn off, it's low, it means off, it would flicker so fast your eye wouldn't even notice. It would just look like the LED's on the whole time. So we have to actually slow it down. So here we're slowing it down, then we turn it off, we slow it down again, and then this loop just repeats forever and ever and ever until you turn off the Arduino. So that's the basics of the program. You can write comments in here, put 2 slashes, and you can give yourself notes. Oh, the reason I did this was, or I tried this and it didn't work and now I'm going to try this. You can actually leave yourself notes, which is a good idea when you're experimenting, because sometimes you try something and you try it for a long time and you forget actually what you did. Okay, so I kind of went over this already. This is just, I guess, a little more clear. Again, the three sections here. Now, the letters, the words in orange, these are specific terms that the Arduino understands. And then you can't really, if you misspell it, it's not going to understand it. So there are certain words you have to get right. I have a sheet that I'm going to post that has all the basic commands that the Arduino understands. I don't want, okay. You guys look like you're getting sleepy. Sorry, I don't want to bore you there. Again, this presentation will be posted online, but for the most of the stuff we're going to do here today, we're just reading, which means we're getting input from a wire, something's connected to the pin, and we're writing, which means we're going to send that information out. And then we're also throwing this delay. One thing to note about the delay is you put the time in here you want to delay, and if you notice back here, the delay says 1,000, right? that really means 1 second, because the delay is in milliseconds, which is 1,000th of a second, if you guys know the metric system. So 1 second is 1,000 milliseconds. So you have to remember that. If you put delay of just 1 in there, that would be a millisecond. It'd be so fast it wouldn't matter. So just keep that in mind. Okay, so now I'm going to show you a few demonstrations. We're going to talk about them, make some changes to them as we go. Again, my colleague Hugo is not here, so we were going to alternate. I'm going to do the game and the sensor input and the drawbot. He was going to do these two things. I don't have the information for those, so I'll just talk a little bit about the Scratch one. Has anybody here worked with Scratch? Okay. So if some of this stuff over here looks too complicated, you can actually download, there's a program you can download where you can use Scratch to program the Arduino. And it's called, I believe that's the one there called Arduino. But we'll have the link for that also posted in all the links. So you would download this program, you can then do things in Scratch, and Scratch will actually turn it into something that looks like this for the Arduino, but you won't have to worry about all that. But it'll have a little block for a delay, and you can type in the number you want for the delay, that kind of thing. All right, so let's look at an interactive game. First thing, so this is my game here, and if you can't see, feel free to come up, maybe take turns since there's so many of you, but what I'm going to do is, in order to give it some power, I got to plug in the USB cable. Oh, yeah. Okay, did everybody hear that? Did everybody hear that? Yep. Did you see the lights going on and off? Yes. Okay. Did anybody recognize what that was? Anybody know that little tune? It's not Pac-Man. You know what it is?
No.
It's from a long time ago.
Yeah.
Yeah.
No. Yeah. What do you think?
Close. No.
Yeah, it's not. It sounds like that. It's not that. You have another idea? What do you think? Let me do it one more time. Just I'm sorry, I can't make this really any louder.
Adults might possibly know.
Yeah, I don't know if kids still use this or not. So that's the thing. Oh no, I'll turn it this way so you can.
It's an electronic game from like 1981 that was popular.
Oh, I know.
Yes, you think it is? Yes, Simon. It was Simon.
Okay.
A little memory game.
Anybody heard of Simon, you kids?
It's a memory game.
Okay, it's like Simon Says. Okay, so again, I didn't write this. I just copied this from online. And what happens is Simon, I didn't notice. Did you notice what light just went off there? It doesn't matter. What Simon does is it flashes a light and plays a sound. And there are 4 lights, 4 different colors. Each color has a sound. So every time the white one goes off, it has its own sound. The red one has its own sound. That kind of thing. And it starts out. It just does one of them, and you have to repeat it back. So I have little buttons on here, and then if you get that one right, it'll do that one again and do another one, 1, 2, and then do 1, 2, 3, and it'll count all the way up, and this one will count all the way up to 100. See if you can remember 100 things in a row.
Random colors and sounds.
Yeah. So I don't remember which one I did here. I'm just going to press one. Oh, I got it right. It was yellow. So now it's going to go yellow, white. So I'm going to repeat that, right? Now it's going to do 3. Okay. If I get that wrong, it does another sound, they flash, and it's going to start all over again with 1. So it's kind of a fun game. You could make this one. This one's a little messy right now just because, again, I'm using the breadboard. Got all these wires over here. This is what's called a prototype. Anybody heard that word before? Yeah? All right, great. Anybody know? You guys know what it means? What's a prototype?
It means like something, let's say you're making a car, so if you're making a prototype, like you don't put like all the fancy stuff like
The first version. Yeah, first version.
Yeah, right. You don't go right. It doesn't look fancy, just like this. You're just trying. It's almost like a proof of concept. I don't know if you ever heard that, but basically you're just trying to make it work the first time, figure out all the little details of it. Then once you get it working, you could actually, you could put this inside of a plastic box. You could make nice better buttons. You could power it with the batteries, and then you could take it with you and play this game. It's not the same as a iPhone app or whatever, but it's something you can do. Now, I'm going to pull up the program for this. Now, this program is a little complicated. Oh, so can you guys see that? Okay, so what? Oops. When you start saving, when you start writing some of these programs or copy them, whatever, and putting them into your own computer, there's an area called Sketchbook, and these have all the ones that I've been working on here. So it's really easy to find them. This one is called Simon Game. Did I miss it?
By the way, when I got Simon, the first thing I did was I made it into a word game. I put little scribble letters on it, and as it was making a pattern, I would build words in my head.
Oh, here it is. Okay. So here's the sketch for Simon. I'm not going to show you all the details in it, but another neat thing about Arduino when you get more into it is a lot of people have created what they call libraries. So Arduino does some stuff already all by itself, right? It's got, and I'll just show you this quickly. Basically, one page, front and back. These are all the basic Arduino commands. So, I mean, you could, I mean, it seems like a lot at first, but you just learn a few of them at a time, and pretty soon you know all of them. It's not that bad. But if people want to do more or things with it that they can't quite do with just those commands, they create these libraries. And so this one has a library called Tone. That's the thing that's making the sounds. And what they're doing is they're just loading all these different, in that Tone library, it defines notes. You know, this is an A, this is a B, this is a C sharp, that kind of thing, all different notes in the musical scale. And what this thing is doing is just pulling those in. So you could go into this sketch, and let's see, down here, see, this is doing a bunch of things. It's it's doing the lights and it's doing the sounds. So where it's actually playing the note is in this area here, speaker, pin, play, note, and it's figuring out which note to play. What you could do is you could go in and you could change, if you didn't like those tones, you could change it to be whatever sound you wanted. You could just pull in different notes. That's one example of a quick little change you could do with this thing. All right, I'm going to move on to the next one. Yeah, let's see here.
Oh, can I talk just for a second about
Yeah.
Arduino invention?
Sure.
So Arduino was invented by some really smart people in Italy. That's why it sounds like it's got an Italian name. And I love Italy because it's also the place where the Renaissance came from, which in the Renaissance, you'll learn in history, was a really interesting time when there was lots of art and lots of science. Anyway, so Arduino comes from Italy. And there's a whole long story about how it came about. And I think I saw something on television about it. If you're curious, you can go and look up what is this origins of Arduino. I think it's about 5 or 6 years old.
Okay. So the next one, so that was just a game. That's sort of, that sits there, and once you load your program up to it, you could go back later and change it, but it's just going to respond to you pushing those buttons. Okay. So another thing is to have the Arduino, I said, give you information about the environment. So I have another little project here. I'm going to connect it. This one has a light sensor on the end of it. This is a real simple little device. Costs maybe $1 or $2, and if you buy an Arduino kit, they always include those. What this one does is it will respond. It'll light up. I don't know if you guys can see this here. There are actually 4 lights lit up right now. There are a total of 5. So if it was really bright, see if I can get this here. See, the 5th one lights up. Okay. Now it's kind of bright in here. So I actually have this little box. I just made a hole in it. Stick it in there. And this thing is still pretty sensitive. Inside this is just an empty box. Inside the box, still one light lights up.
There's a hole there. That's why.
So I have a hole there just to show you that, yeah, even I close, oh, there you go. Yeah, if I close it, right, they're all off. If I open it up, the one light comes on. If I stick a flashlight in there, we should get some more.
Wow.
I don't know which way the thing is pointing. So that's the thing about what I'm trying to show you with this one here is if you, let's say, you know, everything doesn't have to sit together with your Arduino. You could have really long wires. Let's say you were inside, in your basement, and you want to know when somebody was going to pull into your driveway at nighttime, right? So their lights would shine somewhere. You could actually put a little sensor like this outside, run the wires all the way in, and have this thing sitting near you. And maybe as someone drove down your street, you know, 2 or 3 of the lights would light up. But as they pulled up into the driveway and the lights were hitting this thing directly, all 5 would go off. And you know, oh, there's someone there, because maybe you don't hear you can't hear the doorbell down there, or you just want to know when someone's coming to your house. So it's almost like a little detection device. Now I want to show you. So that's just doing lights. Oh yeah.
Can you wirelessly like transmit signals like from the Arduino down to another thing?
You can do wirelessly. You have to buy another little thing. There are little things that transmit RF, radio frequency waves, and there are all kinds of. Actually, let's talk a little bit about that. All kinds of other components you can buy that go with the Arduino. All right. This is another. There are a bunch of things called shields. A shield is basically the same size as the Arduino. It has a bunch of these spikes. You know, they're like really tough wires that they correspond to each of those black inputs that were here. So they line up with these here, and you can just plug these in. I'm not going to do it here because I have wires stuck in there, but you could plug it in. And so there's one of these that's made for that wireless thing. So you'd have one of those on here, and then you'd have your wireless thing wherever else. And as long as they were close enough to talk to each other, they could talk to each other. They also make these to run motors. If you had a stronger motor, you could get that type, plug it here, and it'll help make sure that there's enough power running the motor. So there are a bunch of these things, and you could actually, I've seen online where people have stacked about 4 or 5 of these up on top of each other, and because they're doing all kinds of different things. So there are a lot of things that can go. Once you get into the Arduino, again, the possibilities are just unlimited.
Well, John, I think you had a question.
Another question? Yeah.
Well, I was just going to say, but the motor shield, for example, can you just use a relay?
Yeah, there's not enough power on the Arduino itself I mean, you can open and close the relay, but depending on how you're powering the relay, you probably could figure out how to do it. So I don't want to say no to anything because there are no no's. So all right. So anyway, I want to get back to, so I made a little change. Okay, that was Simon. Let's open up the sensor thing. So I'm going to go back to Sketchbook, and it's called LED bar graph. Okay.
John, can I ask a question about that?
Yep.
So from using Scratch, my students are really familiar with going online and finding a software program and downloading it and remixing it. But how did you see how to make the hardware part? Do they post diagrams?
Yeah, yeah. And there are a couple of really good sites on that. Again, these are in the links. There's a site called Instructables, and it's free to get an account on that. I think it's just instructables.com. They give you step-by-step. And these are just people, anybody. You could go on and post one of these too. Say you came up with a project, you liked it. You give step-by-step. They give pictures. They'll show you, stick this wire here, stick this LED there, and then they'll give you the code for the Arduino. So there are a lot of resources out there. So let's go back to this example where you have this sensor outside in your driveway and this thing's down in the basement with you. But you don't want to actually be looking at it all the time to see if somebody's coming. What if you're reading a book or watching TV or whatever, and you're not paying attention to the thing and you don't notice, right? Maybe Can anybody think of what we could add to this? What do you think? Sound. Yeah. So this is the base. This is the sketch for this one that's in here right now, and all it's doing is you don't have to get into all the details here, but it's lighting up things, right? So I thought, well, let me see if I can add some sound to this. So, and I'll show you what I did. There's a thing called LED bar graph sound. What I did is up at the top here, I used that tone library that the Simon was using, because right off the bat, the Arduino doesn't really have, it could beep or something like that, but you can't give it different sounds. And so this stuff up here, I just copied all this from this. All this here comes from the Simon thing. Just copied all that. You don't even have to know what everything means. And then in the setup area here, remember this is our second, so that's up in our first area, up in our variables and constants area. In our setup area, I put in this speaker pin thing. I pointed that out a little bit before, right? Again, I copied that from Simon, and I said, okay, I put speaker pin begin 12. So I know that on here I've got to find my D12, digital 12, and plug my speaker into that. And here I have just this, there's a tiny little speaker here. I don't know if everybody's going to be able to hear it. It's a real little one. Okay, and then down in the loop here, so I decided, let's see, when all 5 lights go off, that means some really bright light is shining at this thing. That's when I want to hear the tone. I don't care if it's 1 or 2. Maybe that's just somebody driving down the street, and I don't want to hear the thing beeping every time somebody does that. When someone comes in the driveway, so let's see, where do we go? So down here, this is where it lights up, it counts the number of pins or LEDs to light up. And so it's counting with a variable called I right now. And I just goes 1, 2, 3, 4, 5 to count which ones, how many to light up, right? So when I equals, so this little code here, if I equals 5, then speaker pin play note G3. Again, you can put any note in there you want. And then here I also delayed it for 200, which is 0.2 of a second. I don't want it to go for too long, but I want it to go long enough so I could hear it. And then I tell it to stop, just to make sure it stopped playing. All right. So this is all I add. I added that stuff at the top, and then I added just this part here. All right. So now that's not in my Arduino right now. My Arduino just has the basic one. So what I do is see this arrow up here. When I'm happy with or if I want to test this in my Arduino, I just push the arrow and see it says upload over there when I hover over that, right? So it does that. It does some. It's showing you. It's compiling it. It's gonna make sure everything's good. Uploading it. Okay. It says done. Uploading. Right. So we don't hear anything right now, even though we got four lit up. Let's go ahead and add our light here. Let's see. Can anybody hear that? It's really quiet because it's a small speaker. It will. You guys hear that? You guys can verify, right? It's working. So that way, it'll beep while all 5 are lit up. All right, Hugo's here. So Hugo, you ready to?
Let me get a little more. Yeah, sure. I can actually.
Okay.
So John, you pressed upload. I didn't see you press like start or anything.
Oh, good point. Right. When you upload a program, a sketch, to the Arduino, as soon as it says done uploading up there, it's going to start running. And it's just going to run. Like as you can see, the lights are still lit up because this thing sees, you know, it's getting its information says, okay, I have to light up 4 lights right now. It'll just do that forever until I unplug it, because it's getting, right now it's also getting power from the USB. So I unplug it, boom, it's out.
And does it always start from the beginning? Like,
yeah.
If you uploaded something and it's halfway through running something.
Oh.
Well,
so if you're in the middle, let's say.
Like a car going around a racetrack and it's supposed to.
Yeah.
Flash halfway around.
Let's do this. Let's turn on Simon here. Actually, that's not a good example because now it's just waiting. What? Okay. No, actually, this one's a good example. Let's get back here. Okay. So now watch the lights. I'm going to upload it again. I'm just going to upload the same thing. but there will be a point where those lights will go out. See there? Now it says, oh, okay, something's uploading. I'm going to stop what I'm doing. Da-da-da-da. It's done. Now it's running the thing I just uploaded. And likewise, if I unplug it, all right, it stops. If I plug it back in, either a battery or the USB or whatever, it's going to immediately, as soon as it's all powered up, the light should go on there in a second there. That's what I love about live demos. It should just start going. As you notice when I plugged in the Simon, that's not right. There we go. I don't know what was wrong there before. So as soon as you give it power, it will start running again. Now there is on some of them, there is a reset button. Push that button, it'll restart over again from the beginning. So if you had a real long, say it was going to play a Beethoven song or something, and you're in the middle of it and you wanted to start over again, you could just push the reset button and it'll restart again from the beginning. But then that's the thing about Arduino. While it's powered up, it just runs and runs and runs and runs. Ready?
Okay.
Okay. This is Hugo, and he's going to show you some other stuff. You want to plug in here?
Okay. Let's see. Okay, let's see. It's right there. You just have to
Yeah, there's no. That's
okay. Okay, hi, my name is Hugo, and I'm going to show you this other tool that you can use. Right here, I'm actually so this is the normal UI for the Arduino, which is based on processing. But if you're more familiar with something like Scratch, you can actually, there is some people put together this like this tool that makes it really Scratch-like, so you can program Arduino with that. So I'm going to show you that really quickly. Let's see. So it's called ArduBlock, and you click on that, and let's see. And there we have it. So as you can see, for people who have used Scratch before, this should look really, really familiar. For those who are not familiar with Scratch, Scratch uses block programming. So you have like these different puzzle pieces that you put together, and that's how you program. So I'm going to open load. Let's see.
Scratch projects?
Sorry?
Is it Scratch projects?
No, these are not Scratch projects. Actually, that's a really good point. This is not Scratch. This is Scratch-like. It's a different project. It's a different system. Scratch is based on Smalltalk. This one is this is a Java system. So let's see, computer. So I have like the mouse, like the hello world of microcontrolling set up. Let me just navigate there. So it's an ABP, and it's the famous blink. And this is what it looks like. So let me actually. Anyone who has used Scratch before? Yes? Okay. Do you want to come over here and try it? Go ahead. If you've used it before, it should be really, really easy to work it. So go ahead and like just try to manipulate and move around those. Oh, you have to use that here. So just take things apart, change them. The num blocks. May not be. Okay, there you go. So just go ahead and take things apart. So it's basically like little puzzle pieces that you can use. Let's see. Although here the digital pin does have to be 13, so you have to change it back. Did you get to explain what high and low means?
Yeah. Basically on and off.
Okay.
Yeah, I think
great.
I said that.
Okay. Okay, so you change it. So go ahead and save it, and then then in this case you click upload. Let's see. It's not doing it. Let's see. You changed this to 18, so go ahead and change that. Upload. So right there is the light. Should start blinking. This one should be. No, it's not doing it. Let's see. Let's see. Put 15. Okay, so upload it.
We have got such talented kids here today.
So, okay, so that's working. So we switch. Go ahead and do it. Stick it between 13 and ground. So on the board, you can actually see that it's blinking. So let's see. Let me put. There you go. So you can see it. So it's really, really simple to use it this way. Then also the second thing that happens is that as you're writing this, it's being written also in the back on the actual sketch. So if you don't know how to do something using the Arduino language, but you actually want to, but you can figure it out using the blocks, then you can just go ahead and use the blocks, and then this will be written for you.
Hugo, how did you switch that again from the block mode to this mode?
Okay, I can show you. I basically just click back and forth between these two. So this came up, and then I just go back over here.
And that lives inside Sketch, that Ardu blocks or whatever.
The Ardu blocks, no, it doesn't. That's a different. It has. You will end up with two different files. One would be the Ardu block file, and then you will have the Sketch file. And you have to install Ardu blocks.
Right.
Yeah.
If they're running simultaneously, though, they automatically are talking to each other.
Yeah.
Ardu block runs on Mac too?
Sorry?
Is it only for Windows or Mac too?
I don't have a Mac, so I haven't tested it in the Mac, but it should work on a Mac because Ardu block is a Java.
It's Java based.
Is a Java-based tool. Yes. Yeah. So. And let me show some other things that it has. It's a really, the website doesn't look that great, but it's a really, really nice tool. So besides of having like the basic controls and different pins that you can add here, they also have like already, they have like whole boards or modular boards that you can add that has like, there are these things called Tinker blocks. Do you have those? Or?
I do not know.
I just saw them on Radio Shack the last time that I went there. And you have these little tiny units, as you can see up there, that these little boards with these buttons and LEDs, and it looks a lot of fun. And it already has support for that. Then they have support for these boards, digital boards, joystick mode. So yeah, pretty nice.
So those are all things that you can plug into your Arduino. These things,
Yes.
you own them, and then you use this part of the software to program it.
Yes. So if you have these boards and you have Ardu blocks in your Arduino, Ardu blocks is basically ready to be able to communicate with these different boards. Any other questions? Any other questions about this? You went through your three.
I did two of them.
Two of them.
Maybe it makes sense for you to do your other one now since you're there.
Yeah, that's true.
It's kind of related, I guess. So.
Okay, fine. So let's see. I need another. Here. Okay, so the other one is that this is also. So this is basically programming when you have using block programming to be able to program the Arduino. Now the other, so it's very Scratch-like, and the other thing that. Like if you know Scratch, you basically want it would be nice to control stuff in Scratch using the Arduino, and you can actually do that. So let me set that up so we can do it. Let's see. You want to show yours?
Oh, you need time? Okay.
Yeah,
no problem. I know some people walked in since we started. Did everybody fill out a ticket for the raffle? Do I need one? One per family? You guys get one? All right, I have one more project to show you. I'm going to clear some of this stuff out because we need space here. All right, this crazy thing. So I was not sure all of you were here. It has a smaller version of the Arduino. This is called a Boarduino because it's meant to plug directly. It itself plugs directly into a breadboard, and then you could wire it from there. But it's nice because it's smaller. It does pretty much everything the Arduino does. It's just smaller. It weighs less. And so I saw this project online, and it was interesting because so this is called a drawbot. Okay, it's a little drawing robot. You can see it's pretty simple. I've got the Arduino here. I've got some wheels that are connected to servos. Okay, these are things that will turn the wheels, little motors basically. And then I have a Sharpie and a pen in here. Now the guy who posted this online, his project, he only gave a really very basic version of the code, and it just made a circle. So I'm going to show you that, and then I'm going to show you some stuff I did, and actually found some other code somewhere else that I kind of borrowed in and messed around with a little bit to make some different patterns. All right, now the thing about the Boarduino is one of the ways they get it to be so small is it doesn't have the USB device on it. So you have to use a USB cable that is then connected to essentially the USB processor. So there's actually a little chip on here. This chip is on the main, like the Arduino Uno, or one of the main Arduinos, but in order to save space and weight, they pulled off them. You'll find a lot of these miniature versions of the Arduino, you'll need this. So if all you need to do is buy one of these and connect it into a mini USB here, and then you'll be ready to go. Gonna have to. All right. Actually, I'm not going to plug it in quite yet because it's going to start going. Let me pull up my sketch for this one here.
Going to project that.
So let's go with drawbot 1. All right.
Can you also plug in your computer so you can see that on
The projector.
Oh, sorry about that. Thank you. Okay. Well, actually, first, it's programmed to do the circle right now. I mentioned as you turn it on. This one also, if you'll notice in here, this black box here, it's got 3 AAA batteries in it. So it's got its own little battery pack. So actually, to run this thing, I don't need to be connected to the computer. So let's see what happens here. Yep, we got stuck now. I want it right on their table.
That's cool.
And so it'll just do that until it runs out of batteries. So this is, I took the circle pattern and I modified it a little bit. Instead of just, so with a circle, really all you have is you have one wheel going one way and the other wheel going the other way. So this thing just pivots and spins. And you can control, if you want to make a smaller pattern. Now this is a little harder to see, I only have a pen here, but you can use a, I have this set up here, so it'll have a smaller diameter. And it's really, the pen's really faint, hard to see, but well, you know what I could do? So let me put, I can move the marker in there. It's always fun working with things that are like alive. And meanwhile, this little platform here, this is just a styrofoam thing that I think sushi or something came on it from the supermarket. So, ah, hang on. Okay. Now, as you can see, it's doing a smaller version of what it just did. So, you know, you could actually, or you could put two markers in at once, and it would do one inside of the other. All right. So let's take a little bit of a look at this in the code here. Oops. Can you grab that for me? Thanks, bud. All right. So I'm going to. Yep, the basic. I'm going to pull up the one I actually have all the different things in there. So it's drawbot 2. So, you'll see here I've commented. Remember I was mentioning that to if you put 2 slashes in front of something, and maybe I didn't even explain this very well again or before. That makes it a comment. In a comment in computer code, the actual computer doesn't care about it. It's really just for you, the user. It ignores all that stuff. So I have a bunch of different, I have 3 patterns here. I have something called feather pattern, circle pattern, and the saw pattern. That's what I'm calling the saw pattern, because if you look at like a circular saw blade, it's kind of like that. So what I can do, let me show you what those are really quickly. I don't want to bore you, but this is the stuff I copied from someone else. They came up with the commands forward, reverse, turn right, and turn left. I just copied that from somebody else's. But I added a little thing in here called reposition. And
That's all right. That's okay. Don't worry.
You'll notice up here, here's where reposition is. That's almost also commented out. I mean, it kind of makes, that's kind of a neat little pattern there, you know, but it's kind of repetitive. What reposition does is it just moves. It does that a few times, and then it moves out. It turns right, and then it goes forward, and then it starts doing it again. So it'll do that, and then it'll move and do it again in a little different place. It'll move and do it again in a little different place. Then here's the feather one, which is just, it goes forward, and then we delay a little bit again, because if you just did forward and then reverse, it would go so fast that it would just make a little blot on there. So you got to give it some delay. So let it go forward a bit, then it goes reverse, then it turns right, then it turns left, then it stops, and then that part will just repeat. The circle is just using the turn right command. Okay, now let's look at what is the turn right command. So it has the left servo. All right. So when you take these. This is two different servos here, right? 2 little motors. And when you put them like this next to each other, one's really backward of the other one, right? So if you tell, the way you make these things move, you put numbers in there from 0 to 180. I think 180 is the top number. I'm not 100% sure on that. But so what happens is if you put these 2 motors side by side, but one is actually reverse of the other one, and you give them the same number, one will spin one way and one will spin the other way. So circle is real simple. It's just turn right, and we just keep turning right. We delay a little bit to let it go, and then it turns right. And then the saw pattern is forward, left, So what it does is instead of just, we could have done forward, right, just like the circle one. But what it does is it's making the circle, but then it goes forward a little bit. And that's what this little, it's making the circle, then we go forward, making the circle go forward. So let's put another pattern in here. Let's do the feather pattern. Okay, and then I'm also going to put the reposition thing in there so you can see that too. So all I'm doing is I'm taking out the comment. I take away those 2 slashes, and all of a sudden you saw it got a nice bold color here. It's not this grayed out color, which means now that command is available. The Arduino is going to see it. I'm going to save this. Now to upload it, I have to pick this up again because as soon as I plug in, it's going to start moving. All right, and you'll see it'll stop when it It uploads. Oh, I have to change. Oh. So here's another thing. I switched from I was using the Arduino Uno before. Now I'm using the Boarduino. I actually have to go up here and tell it which board I'm using. It thinks I'm using the Uno. I have to tell it to use this one, which happens to be the same thing as the Boarduino. Okay, and then you'll see it was telling me. Okay, I think we're okay now. Oh, we have to change the COM port. So we just say okay here. If it does that, sometimes when you plug things in and out, it thinks it's in a different port. So now you see it stopped, so it's receiving the program, the new program. Now it says it's done. Okay. There we go. So what I'm going to do though, I'm going to unplug this because I don't want to have a wire on there because I think I might cause a disaster if I have a wire on there. Oh, thank you. And I'm going to put this out on the edge again, just to give a little more exaggerated pattern. And let's see what happens. I should have brought a marker with a different color. Okay, that was the reposition there. I don't know if you noticed it. I got to move this over here. It's going to go off the table. But so all it's doing is it's a circle and up, a circle and up. I mean, part of a circle, an arc, right? A little bit of a circle and up, circle and up. And it does that. I forget. Maybe you could count how many of those things are. Maybe 10 times. Then it did that thing where it went forward and moved left or whatever my reposition was. So that otherwise it would have just gone in a circle and did that. So now it's doing this, and it's going to reposition here pretty soon. There we go. There's a reposition, right? And if you let it do, I call this a feather, because if you let it do this a whole bunch of times, you can see now how it's like that. It kind of looks like it'll keep coming this way. It's falling off the table. It'll keep coming this way, and like that. And when you do about 10 of them in a row, it looks like a feather pattern. So that's simply done, through this by just telling it to do turn left, turn right, go forward, stop, different patterns. Now another thing you could do, which I would have liked to have done, but just didn't have time, but you could come and measure how far this forward is. It almost looks like it's about an inch when it goes forward there. So you could figure out how much delay did I give it? Did I give it a second? And you could figure out, okay, a second is equal to an inch going forward. And how far does it go to the right? And you could measure that. And so you could actually figure out, if I wanted to draw something that was 2 feet by 3 feet, you could go in and well, I know a second is an inch, right? So you could figure out how many inches are in 2 feet. Anybody? How many inches are in 2 feet? Anybody? Just shout it out. 24. So you would then, if you knew a second was 1 inch and you wanted to go 24 inches, you would just put in 24 seconds. You know it's going to draw something 2 feet long. So that's one way, and you can just go in and tell it to turn right, mess with different patterns. You could even, there's a random function in the processing language. So you could have it do some random patterns and things like that. So just to give you an idea there. Okay.